Hello, everyone. So this is a question on the MATHCOUNTS chapter theme run. So this was question number 8. Okay. So we have a quadrilateral. Okay, A, B, B, C, C, and A, B is given, and we are given two perpendicular segments. And then what is the least possible area of the region? Okay. So it's better to start with drawing a figure to see how that looks like. Let's go with maybe this is A, this is B, so that is 3. And we are told BC is 4, AB and BC is perpendicular. So let's make a perpendicular segment. Okay, so we are given this is 4. So let's say this is C. And AD, CD is given. So CD and AC is perpendicular. So A right here. So we should have AC, something like that. And CD. So these right here. So maybe I can extend this something like this, because at the end, when I connect AC and CD, I should get a 90 degrees. Okay, so it looks like has to be, let me connect these two first. So I should be expecting something like this, right? And then let's connect those. So that is D. So CD was 12 and AD is what? It's 13. Okay, so this was 90 degrees, so 3, 4, so that is Pythagorean triple. So if you remember the previous problem, so that was just asking the Pythagorean triples, and this is now an application. So 3, 4, 5, so that's 90 degrees. And then we have 5, 12, and 13, which makes this guy is also 90 degrees. And if you add the areas, the ABC is just 3 times 4 over 2, plus like ACD is 5 times 12 over 2. So that's 6. That is 30. So that looks like 36. So we got this guy, right? But I have a question. Like, this was a number 9, and then we got the answer really easily, which is a concern. And also, the question was asking something about the least area. We just got an area which doesn't look like we have like least or the largest area. So that is why I wouldn't go with this immediate, especially for the number 9, okay, to number 8. So maybe think about the figure and see if you can make this given figure in a different way that will give us a smaller region. So what I can maybe try, we have this triangle, let's write triangle. This is also a triangle. Is there any way for us to like place this smaller triangle inside of the larger one? So by doing so, we can actually have lesser area. So let's try and see. So I'm going to have a bit bigger triangle. Okay, this is my 5, 12, whatever. Okay, so this is 5, and this is 12, and this is 13. So that would be 90 degrees. So my goal is just to have a quadrilateral that will be like this smaller triangle will be inside of the larger one. So is it any way we can place like we can do such a thing, something like this, right? So we can have this triangle and place inside, which is, I guess, possible. Okay, so we could have something like this. And then I can say, maybe this is AB. So this is A and B, and this is C. And if you look at this figure and this figure, everything in terms of the segments are correct, right? So AB is 3, AC is 5, and BC is 4. But now, this smaller triangle is inside of the larger one, which means the area of this smaller triangle doesn't really matter for us to get the full region, right? Because that's basically the area of the triangle right here. So let me call this indeed. So the question might be asking this region, right? So this is my list region. So A, B, C, D. So this is still a quadrilateral. It doesn't have to be convex, but usually we try throwing a convex, but it could be concave, which in this case is much lesser area compared to this guy. So then the area will be, we had 36 for the larger one, and we had 6, no, that was, okay, let me see. So the larger one was 30 actually. Okay, and the smaller one is 3.5, which is the area was 6. So if you subtract that, so you get 24. As you see, this is another area that is achievable, which is actually the answer. So I hope that makes sense. I'm not sure why I'm doing this, but because I did a lot of work and then I just wrote it 30 some reason, which is why it's better for us to be really careful while we are writing the answer or reading the question and think about all the choices. So that would be my answer for number 9. So I hope that was clear, and I'll see you in the next video.